A manufacturer claims that the average lifespan of their batteries is 400 hours with a standard deviation of 40 hours. We want to test that claim. To test that claim, we obtain a random sample of 30 batteries. Now, why 30? We should have minimum of 30 in our sample because we don't know the distribution of the population and whether it's normal or not. But by getting a sample of 30 or more, we ensure that the distribution of the means of samples is normal, and that's according to the central limit theorem. So we have a sample of 30, a random sample, and we calculate the mean lifespan of those batteries to be 380 hours. Does that tell us, what does that tell us about the population mean? So to answer that question, we have to figure out what is the probability that a sample of this size, 30 batteries, would have a mean of 380 hours or less. Okay, so given that the population mean is 400, and remember from the central limit theorem, the standard deviation of the distribution of sample means is going to be the population standard deviation of 40 divided by the square root of the sample size. So in this case, 40 divided by the square root of 30. That's the standard deviation we're talking about now. So what's the probability? So let's put that here. What's the probability going to be? Let's figure it out. So we go to fx. We go to normal distribution. So remember, we can use the normal distribution for this because we have more than 30 in our sample. Click OK. X is what? X is the value we got, the mean we got of 380. The mean that manufacturer is telling us is 400. The standard deviation now is not 40. Remember, it's going to be 40 divided by the square root of 30. So 40 slash, I'm going to put in parentheses 30 raised to the 0.5, square root of 30. So the standard deviation is actually 7.3. Cumulative, true. Okay, so our probability that we would have a mean of 380 hours or less from a sample of size 30 is 0.003. Very small. So what is that telling us? That tells us that there's a 0.003 probability we would get a mean of 380 or less given that the population mean is 400 with a sample size of 30. So in other words, since 0.003 is less than 0.05, remember that cutoff that we use? Since 0.003 is less than 0.05, that 5% cutoff, there's evidence to reject or fail to accept the claim mean of 400 hours. That 0.003 is sometimes called the p-value. So we have evidence to not accept that claim that the manufacturer is making because there's a very small chance that we would get a mean of 380 from a sample size of 30 if that were true. Another way of looking at this problem is to construct what we call a confidence interval for the true mean based on our sample. To do that, we have to go to, again, let's go to an empty cell, click on fx, but this is a different function. Let's look at what we call a confidence interval. And here we have it, confidence norm. So norm we're going to use because we have a sample size of 30 for normal, so it makes it normal. Click OK. And we're going to put in our function arguments here. Okay, this is very important here. Alpha is 1 minus or 100 minus 100% minus the confidence level we want. We want to be 95% confidence, so alpha is going to be 5% or 0.05. The standard deviation, we have to read this. Before we had to put in our standard deviation exactly as it was because based on our sample size. But this particular confidence interval function in Excel allows us to put in the population standard deviation. If you read down here, the population standard deviation 40, because it's going to calculate the standard deviation for the means based on the sample size, which is the next thing we have to put in. What is our sample size? 30. And so if we click OK, what we have here is what we call the error, the plus or minus, the error from our mean. Okay, and so our true confidence interval, that's going to be equal to my mean plus or minus this error. What does it mean we had? Well, we had a mean of 380, and then we're going to subtract off this value. So from 365 to And the the top upper limit is going to be 380 equal 380 plus this error. And so our confidence interval is from 365 to 394. So what does that mean? Technically what it means is 95% of intervals calculated in this manner will contain the true mean. So we're 95% confident that the true mean is between 365 and 394, and that means that, notice 400 is not in that range, and so we're 95% confident that the true mean is actually less than 400. Now of course there's a 5% chance for error. That's what the 95% means. But this is another way to test the claim of 400. We have enough evidence at the 95% level, you could say, to reject that claim, or at least not accept that claim that batteries are lasting on average 400 hours. We think they're lasting less.